So getting back into your book, right? Just talking more about the preface, I noticed that you have the word causal inference revolution is an intellectual revolution. Why do you
Mhm.
say so?
Yeah, so it's funny because I um I wrote that before reading the Book of Why, and then I realized the Book of Why is by Judea Pearl. It's also part of his narrative that we are going through this revolution. So it was funny to see, maybe people will think that I took this from Pearl, but actually it was from just, I mean, to me, it's clear that a lot of scientists were struggling with causality, a lot of tools that they used. So, for example, in epidemiology, we have these designs that are made to make sure that we are not measuring effects that are not causal, that are confounded. Or in social sciences, we are taught that we should adjust for certain differences in our models, things like that. And all these concepts are causal, but we were lacking the theoretical, and when I say theoretical, I guess I mean mathematical language to express these ideas. And a lot of science, when we are able to formalize the ideas mathematically, that is when we really understand them. So I think the revolution, and Pearl says the same thing, is really about finally, after all these years of struggling with causality, we finally have a mathematical language to express what we mean. And this generates a huge advance for science because now when we talk about causality, it means something very concrete. So we can debate about that and not be stuck um, in a sense with philosophical, in philosophy, the debates, they are very interesting and they progress, but it is very hard to progress on causality when there is no formal language to express it, right? There is different points of views, different words. We get stuck with definitions. Now we have mathematics, so we can debate about that. And I think when I read Pearl or even Rubin's work, you realize that again, all this has been kind of bubbling in the back of scientists' minds for a long time. It's just a good scientist did it intuitively. They understood how to make sure what they're doing is causal. But now we don't need to just do it intuitively. We can actually have more rigorous tools to do it formally. And these ideas, um, for example, the counterfactual or the potential outcomes ideas of Rubin, he attributes them to the time of Fisher and Neyman, and he has a very interesting paper where he says, well, yeah, we call it the Rubin model, but I didn't really invent this. Like Neyman did it in the 20s. It's just that it was never pursued, or they didn't grasp how fundamental the idea was to talk about the unobserved value that we would have seen if we had withheld the treatment or something. So all that to say is that I think it was a long journey, but now it's like we are in this explosion of causal knowledge, and every field is interested in it, in empirical science, and even in industry, there is a huge interest to augment data science with causal understanding and things like that. So I think that is the revolution.
Great.